is it true that any set unioned with itself is just going to be the same as the set itself? Or if any set A unioned with A is just going to equal to A. Well, what does this mean visually? Well, this means that if you were to take a set A, for example, and union it with itself, so draw like the same thing over itself, and then you ask yourself, well, you want the union of it, so you want all the elements in both of these, so you're just going to circle or shade the entire area you're interested in. Is that just going to equal A? And the answer is yes. See, when we shaded this in, we just shaded in all of A, so this does look like it's going to be true. So let's go ahead and show you and try and prove that maybe. Okay, so in order to prove this, we have to understand this is an equality, which means that in order to show that the left-hand side is equal to the right-hand side and the right-hand side is equal to the left-hand side, we need to show that the left-hand side is a subset of the right-hand side and the right-hand side is a subset of the left-hand side. Why did we have to do this? We have to show every element here is going to appear here, and every element here is going to appear here. Or more explicitly, every element you're going to have on the left-hand side is going to be an element on the right-hand side, and every element you have on the right-hand side is going to be on the left-hand side. That's what these two mean. And both of these must be true in order for us to state that they are in fact equal to each other. So these are the two things we're going to try and prove. Let's go ahead and try that. So to start this proof, we have to realize this is a for-all proof. How is this a for-all proof? Well, we don't have any restrictions on our set A, so A can be literally any set. So it's for any set A, or for all sets A. So how do we start our for-all proofs? We start with a let. So we say, let A be a set, right? And now we can get into our two cases I mentioned earlier. Okay, so the very first case we're going to try and prove is that A union with A is going to be a subset of the set A. How are we going to do this? Well, let's go over here and conceptualize our logic for the proof. Let's do like a sketch of a proof. So we're going to want to start at A unioned with A and get to A. How are we going to do this? Well, we want to show that every element here is going to be in here. So let's just create some arbitrary element, right? That's what you do for all proofs. And when you do this, this element here is really representing every element possible in A. X is a representative of everything you can have in this set here. And because this is representing everything, and we want to show that everything here is going to be here, we're going to want to show that X is going to be an element of A. So now all that's left to figure out is how to get from here to here with our math. So how are we going to do this? Well, let's unpack our definition up here. What is this going to be? Well, for A to be a union with A, it means that A must be an element of A, or A must be an element of A, right? That's what union means. It means it has to be in one of the two sets you're looking at. Just to be more clear, this is our start, and this is our goal we're trying to get to. And of course, you could see here that in both cases, X is an element of A, so you can just immediately get here, and you could just say, well, there we go. We've shown that it is in fact true that anything here is going to be in here, so that makes this a subset of that. So let's go ahead and write that down in our actual math proof. So what are we going to say? First, let's introduce an arbitrary element. Let's use our X here. So we're going to say, suppose X is an element of A union A. Fantastic. Next, we're going to want to explain this logic here. We're then going to say, then X is going to have to be an element of A, or X is going to have to be an element of A. Fantastic. And then we just need to connect them to what we want to prove. We want to prove that X is going to be an element of A. So we've already shown that, and we can just say, in both cases, X is an element of A, making, and now we can just conclude what we wanted to show, making A union A a subset of A. So there we go. We've shown our first case to be true. Now let's go ahead and try the second case. So how are we going to approach our second case that must be true? Well, we're just going to flip our start and goal, right? Now we're going to start with A, and we need to somehow get to showing that X is going to be an element, or maybe let's use a different variable just to not confuse the reader. We're going to show that these are distinct cases, right? So let's not reuse the same variable. We'll use Y. We have to show that Y, that represents every element in A, is in fact an element of A union with A. So where can we go from here? Well, we can say that you can't really break this apart. You can't just say, well, y is an element of something. You can break it down further. So maybe we can generalize it in this case. Maybe we can say something like, we can just reverse our proof here, I'm thinking. We can say, well, this means that y is an element of A or y is an element of A, right? Both of these, like this statement here, if this was just a sentence, is true. This still works with this assumption. And then we can say, well, if this is true, then of course, well, maybe we just keep it as one statement. So instead of having two arrows, goes to one, and then this goes to one. So our proof here is actually a lot simpler going the other way. We say that if this is true, you can break this up into this statement, which means that this is true because this keeps that true. And when this is true, you can write it as this. So let's go ahead and write this down in our actual mathematical language. So what are we going to do? We're going to start similarly to how we started with case one. We're going to suppose our element, our representative of the set we're starting with. So we're going to say, suppose y is an element of A. And now we can say, then, now we're going to get to our second line, then it is true that y is an element of A or y is an element of A. So then y will be an element of A unioned with A. Well, there we go. So we've just shown what we needed, and now we just need to summarize that because every element in A is going to be an element of A union A, that makes A a subset of A union A. So we could say, therefore, A is a subset of A union A. Fantastic. So we've proven our two cases. All that's really left is to write our conclusion. So we can say, in conclusion, given that A union A is a subset of A and A is a subset of A union A, I'll just put a comma down. Given that this is true, then, comma, A union A is equal to A. There we go. We have proven that this is in fact going to be true.